Welcome to the course on Introduction to Electrical Engineering. So, today we will discuss lecture 4 on the analysis of DC circuit. Well, plan of the presentation or outline of presentation starting with the introduction. We will talk to star connection, then delta connection, delta to star transformation and star to delta transformation. Then we will discuss about the equivalent resistance of the circuit. Then we will like to discuss about some exercises and numerical problems followed by references. So, coming to the introduction, to this DC circuit, as we are talking about star delta connections. So, star connections are generally used in long distances transmission line as insulation requirement and is less in star connection, because star connection you can call it like can withstand higher voltage compared to delta connection as far as per phase voltage is concerned, because the voltage is normally in the system of line voltage, but here certainly the connection is corresponding to the star connection like. However, the delta connections are used in distribution network for short distances, when from the distribution transformer to different household or different loads which are distributed on the distribution transformer like. Then the alternator and generators are usually star connected, and why they are star connected, as you can see the here of 600 megawatt turbo generator at power plant. The reason being that you need the star terminal as a neutral terminal to connect the single phase load, because you have to feed not only 3 phase, but you have to feed the single phase load. Moreover, it is also used for the purpose of the protection in the generator systems like. Then we of course have a transformers, which we discussed. Transformers are extensively used on generation and or at generator terminal to increase the voltage of the generator to the level of transmission. So, as well as on distribution side to reduce the voltage from the transmission network to bring to the distribution network. So, transformers are normally connected in a star delta connection. Of course, they are used in star delta as well as delta star connection, depends on where we are using. So, at the time at the closer to the, you can call it like a distribution, and we connect like a typically delta star, and because to provide the star as a neutral as a specific case. Otherwise, in primary distribution normally these connections are star to delta connection of the transformer. Well, AC motor windings are connected in star delta connection depending upon the requirement. So, in some cases the AC motors which are driven by now different inverters, they are connected in normally in a star, and which are of course to be used with the star delta starter, they normally connected typically finally in delta connection, but of course, we start with the star connection and finally convert into the delta connection to run at full voltage like. But of course, this star delta conversion allow the you can call it to reduce the inrush current in the motor winding as well as from the supply drawn from the supply. The reason being that initially it reduces the voltage across the winding in a star connection by 1 by root 3, and later on when it connects to delta, it apply the full voltage across the each phase winding like. Well, star delta starters are used for starting like a many motors, 3 phase motors like a compressor motor that need the kind of many applications like pumping application, fan applications, like we use not too much high starting torque. So, certainly we use the star delta starting for that. So, motor is initially connected in a star and finally goes into the delta, and these star delta starters are very extensively used in large number of applications for the motor rating more than, typically you can call it 5 HP or more than 5 HP or 3.7 kilowatt or higher rating, provided leaving exceptionally some typical advantage applications like. Well, normally the power capacitors in 3 phase capacitor banks are also connected either in delta connection or star connection. As you can see as here delta connection, these capacitor banks are used in case of even a end of the transmission line, as well as they are used in distribution system at the substations. The very purpose of this capacitor banks is to meet the reactive power requirement at the substation or at the, you can call it at the place where they are connected. So, they provide the reactive power to the system, especially in the AC system. So, they are connected either on star or delta, in both the connections they are used, depends on the application requirement like. Then similarly, we have a shunt reactors operating as a load between phase and neutral or ground with for the star connection or between the phase edge, of course, with the delta connection. They are also used in many substations, I mean like typically again for meeting the reactive power requirement, like with power switching arrangement, like I mean of course, in shunt reactor sometimes are operated even the phase control manner by the control solid state control switches, like I mean also. Well, the star delta connections are used in the starting of 3-phase induction motors using star delta starter. As you can see the photograph of star delta starter with the motor, and this star delta starters nowadays are automatic type of starter. So, initially when you switch on the supply, the motor is I mean the connected in star winding is connected in star, because the 6 terminals of all 3-phase windings go to the this starter. So, initially it connect to line with the star connection, so that the voltage across the phase winding is reduced less than 1 by root 3 the line voltage of the supply. And once motor is started, either with the time delay or with the current, I mean depends on current limit, is converted into delta, finally running the motor at corresponding to the full load, like. So, these star delta starters are, most of the starters are now automated, automatic type of star delta starters with proper protection. Earlier of course, they were the manual. Initially you have to connect the in star connection and finally in delta, but both these winding virtually are by this proper connection of this you can call it electromagnetic switch. I mean we connect in star as well as in delta, depending upon the, I mean whether you are starting and finally it is running, like also. So, similarly, the generating transformer near to the power plant generator are connected in star connection to provide the grounding protection through the typically in the transformer, I mean for the system. Similarly, the diesel generators neutral is obtained from star connected star point of the generator, which is used to provide the earthing for safety as well as to provide the neutral for the feeding the single phase loads. Then the of course, earth rods are in star configuration are installed closer to the surge arrestor and high voltage electrical equipment for the purpose of safety, like to provide the very low, you can call it the very low resistance path for the lightning and other surges in the ground, so that the equipments are safe. Human beings as well as the equipments are safe, and these lightning very high voltage spikes are taken care by these, you can call it like surge arresters and grounding system, like by these are. The application of such connections is also used in a high voltage direct current system, because on both the side of high voltage line we have a converter station. I mean on the one side we convert, of course, I mean both the side we convert from AC to DC to bring on the DC line. This HVDC line have a very specific advantage, because the number of the conductors in HVDC line reduces from 3 to 2. Moreover, I mean you do not have a many effect in case of the DC, because you do not have either power factor effect, as well as you can go higher voltage, you can transmit the more power from the DC compared to the AC on high voltage transmission system. So, there are plenty of advantage of HVDC system. We take care with I mean in spite on both the side we convert into you can call it the converter station, but of course, converter station also have the transformer on both the sides. So, these transformers are also certainly connected in with the these connections of star delta connections, because converters are there. So, you have to feed it. Typically, we use the 12 pulse converter. So, you need the type A 2 sets of the 3 phase winding with the phase staggering. So, transformer provide that purpose also with the proper connection of this star delta configuration, like on. Then the delta star starters are installed in cement industry for high inertial load applications, and of course, so these are applications of your star delta connection, and the application of such connection is also used in a Wheatstone bridge resistance measurement device, I mean which is quite famous to measure the resistance of a unknown resistor or unknown equipment for which we want to measure the resistance, like on. And of course, star delta transformers and equivalent circuit calculation help in simplification and understanding of complex electrical circuits. Well, star delta connection is also arrangement of passive element resistance, inductance and capacitance, such that form stage resembles a star or delta symbol, and these connections are neither in series or nor in parallel. and such connections are also simplified using a star to delta or delta to star conversion, and such connections are found in complex DC circuit like a full bridge rectifier, and such connection also have large application in 3-phase AC system. Now, coming to the discussion for star connection, I mean the representation for star connection is typically the Y, or you can call it like a 3 resistors are connected in a fashion to form a T network. So, you will find the symbol for star connection either Y connection or these T connections of the 3 passive elements. They may be equal or they may not be equal, they may be unequal also, but you can connect in this manner the 3 different resistors or 3 inductor or 3 capacitors. I mean also of course, in DC we use certainly the resistor only, and these T connections of course, this is the one way the star network can be rearranged to form of the T network to star looks like a typically the Y connection. I mean like, so it's also can be these resistors are connected in Y or star fashion. A common node point of star connection is known the neutral, as the end point is shown here, and this end point have a specific purpose as a neutral connection for providing the, let us say, the typically additional terminal for typically for the single phase load or for having a measurement corresponding to the phase voltage or phase quantity like I mean. So, there are 3 ways in which star connection may appear as a circuit. You have a first as a Y connection, then you can have a T connection, or you have a typically the kind of star inverted Y connection like. So, these are the 3 ways how we present this star connected network of 3 resistors like. Then we go to the delta connection. I mean typically the delta connection when a 3 resistors are connected in a fashion to form a closed mesh, that is the symbol for the mesh means, and connection form known as a delta connection. It is a kind of like a delta mesh connections, as you can see here with the 3 closed path of the 3 resistor with the ABC terminal, and these resistances of course may be equal or unequal as we discussed earlier in case of a star connection. Well, there are again 3 ways to connect these connections. Maybe you can connect typically as a upper delta or inverted delta connection, or you may have a like a pi network to connect it in the last symbol like. I mean, so all the 3 symbols are normally used in the circuit networks to just suit the specific you can call it the space in the you are drawing the circuit like. I mean. So, now coming to delta to star transformation. So, 3 resistors RAB, RBC and RCA connected in delta, and its equivalent star connection with the typically RA, RB, RC are shown here in this figure. So, these two can be on the terminal, they can be represented equivalent. It means you have been given like value in the delta, then you should be able to calculate the equivalent network impedance or resistance in the typically in case of this star connection from delta connection. So, we have to look into the term, I mean typically the simple mathematical analysis to have the interrelation between the 2 sets of network, one in delta, another in star. So, if one is given, then you should be able to calculate the elements of the another connection like. So, typically coming to here that 2 elements are shown here electrically equivalent, and resistance between AB for star, resistance between AB in delta we have to make equivalent to that. I mean, so you can take 2 terminal like AB, BC, CA. So, you have to write 3 equations from the both the network of delta and star. So, as you can see typically, I mean if you look into the first connection, I mean you can just see from the star side you have a RA and RB connected between A and B network, and however from delta network you have a RAB coming in parallel with the your RBC and RCA, and from this you can write a relation of equivalent parallel like RA plus RB equal to RAB in parenthesis RBC plus RCA divided by RAB plus RBC plus RCA. So, this is the one equation I mean between the terminal A and B. Similarly, you can write 2 more relation between terminal resistances between the 2 terminals like BC and CA, like for the typically for the terminal between B and C it will be RB plus RC equal to RBC in parenthesis RCA plus RAB divided by RAB plus RBC plus RCA. Similarly, for terminals CA, 2 terminals CA also you can write from these 2 network the equivalent like RCA plus RA equal to RCA in parenthesis RB plus RBC divided by RAB plus RBC plus RCA. Using these three equations, of course, we can find out the elements of a star connection in terms of delta connection network. So, you can call it the objective is to find out RA, RB, RC in terms of RAB, RBC and RCA, and substituting 3 from 2 and adding 4, one can obtain RA equal to RAB, RCA divided by RAB plus RBC plus RCA. It is very easy to equivalent. If when you overlap it, you are finding the resistance between the neutral to A connected to A terminal. So, both the side of the branches connecting of the delta of the two sides, you have to take both the resistances like it is shown like RAB and RCA and divided all the three sum of this, all the three delta connected resistances. So, it is very simple to remember. I mean, you can find out kind of equivalent from these, to every time prove this relation. So, similarly, RB will be the two resistance connected between to B terminal, those are RBC into RAB divided by all three resistances of RAB plus RBC plus RCA. Similarly, for RC, the two resistances are connected from the delta network is RCA and RBC divided by all the three resistances of delta connection like RAB plus RBC plus RCA. Well, the same way it is shown here, it is easy way to remember the delta to transformation from this figure shown here, that arm of the star connection, like typically for the let us say A, it will be product of two adjacent of the delta like RCA into RAB divided by sum of all three arms of delta connection like RAB plus RBC plus RCA. That is the easy way to remember for this conversion from your delta to star connection to find out equivalent network resistances in the two connections like also. So, that now we go to the reverse transformation, star to delta transformation, because you can have a network connection of the star and you want to get equivalent value of delta connections. So, here it is shown three resistances RA, RB and RC are connected in star and its equivalent delta connection is shown in this figure. So, one side on left side is star connection from which we want to find out equivalent to delta connection network here like. So, now from these two connections again shown in the figure. So, we can find out what will be the typically the relation, typically your RA relation. Earlier we have this relation we have written already for delta to star connection. So, these three equations already with us. Now, from these three equations only we can of course to have a substitutions or modification. So, what we can do, we can by dividing 5 by 6 we can have a RA upon RB equal to RC upon RBC. Similarly, from this we can find out RCA will be equal to RA into RBC upon RB, and again we can find out from RAC RA divided by RC equal to RAB divided by RBC, and similarly RAB will be equal to RA into RBC divided by RC. So, another equation of course, we can now find out what will be the RBC from these two, from those equation of 9 and 11 into 5. So, RB plus RC plus RB RC divided by A, and this will be equivalent to, you can call it like if we are finding you can call it RB, the branch which is connected between BC. So, we have to take the let us say all the two sets of resistances RA RB plus RA RC plus RB RC divided by RA, which is just exactly perpendicular to the let us say resistance connected between star to A, that is RA. Similarly, we can find out RBC will be also RA plus RB plus RA into RB by RC. So, that will be again too easy to remember, multiplication of all three terms or all three resistances in star like RA RC plus RB RC plus RA RB divided by RC, and similarly the third branch of the delta connection will be RC equal to RC plus RA plus RC into RA upon RB. So, it is very easy to remember if you look into from this notation. So, that will equal to RC into RB plus RA RB plus RC RA divided by RB. So, that is have easy transformation from your star network to delta network like. Well, to start to delta transformation, the note is the resistance between two terminal of delta is equal to the sum of the star resistances connected to those terminals plus the product of the two resistances divided by the third resistance like. So, the very purpose here is like typically you want to find out like RAB. So, you have to take a sum of your R A plus R B, and then plus your, you can call it R C divided by this R A. So, that is easy to remember the relation as we discussed earlier. So, now you can call it for this conversion, if a star network has all resistance equal R, then it is equivalent to in delta conversion have all resistance equal to 3 R. So, you can call it the value of resistance will increase in the you can call it element value increase when it is connected into delta. I mean like, because it will experience the higher the voltage. So, to take care of typically the same amount of current, we have to increase the resistance 3 times equivalent like. So, if delta network has all equivalent resistance to R, then its equivalent star conversion have a all equal resistance to R by 3. So, that is very easy. It means you can call it the typical impedance or the resistance in case of delta is more compared to star. So, that also will keep, because there is a relation of 3 R and by R by 3 only here like, to remember like. And this is typically the summary of this transformation, that you have a circuit of star and delta, and here star is written typically with the Z A, Z B, Z C, and delta network is written like Z 1, Z 2, Z 3. And this relation, of course, what we already talk about, means in that case Z A will be your, in case of delta, Z 1, Z 2 upon sum of the all 3, Z 1 plus Z 2 plus Z 3, and well, when you have all 3 elements equal, then your Z A equal to Z B equal to Z C will be Z by 3. And if you have a like a connection, your typically in case of your you want to find out delta star to delta. So, Z 1 will be, again we discuss it, Z 1 will be equal to your Z A plus Z B, because that is the 2 branch between terminal plus Z A Z C divided by Z B. Similarly, Z 2 will be Z B plus Z C equal to Z B into Z C divided by Z A, and Z 3 will be Z A plus Z B equal to Z A Z B by Z C, and where if all 3 elements are equal, then your Z 1 equal to Z 2 equal to Z 3 equal to 3 Z Y. So, this of course, is the summary what we really have the two sets of the transformation final form like. Now, coming to equivalent resistance. The equivalent resistance of a circuit or network between any of the 2 points or terminals is that the single resistance which can replace the entire circuit between 3 points or terminal between A and B. I mean, where the R 1, R 2 are shown here in series and R 3 in parallel to this network, that is equivalent to equivalent resistance in A B will be, you can find out typically from there to you can sum and then parallel to that. So, that can be represented as a parallel network like. So, coming to typically a star delta circuits, these circuits generally process a star delta configuration and have need to simplified using the necessary transformation and are converted into series parallel circuit. So, you have a battery here and connected to a 4 resistance network R 1, R 2, R 3, R 4, and with the R L between connecting the 2 other terminal which are not connected to the battery. So, neither they are series or parallel circuit. I mean, this is very specific configuration. You can just look into that 2 nodes are connected with the star configuration, and of course, upper and lower triangles are with the delta configuration like. So, this net the circuit is a combination of neither series nor parallel circuit, as you can see here the 4 resistance equal, they are forming a all 4 branches with the internal resistance also R. So, neither it is series or parallel circuit like. So, you can find out equivalent resistance of this star delta network. So, rule is such circuit form a star delta and use the star delta transformation and convert the equivalent series parallel circuit, and changing delta by points of this A B C here, you can convert equivalent to the star. So, R y will be R into R divided by R plus R plus R. So, it will be R by 3, and the circuit form is now combination of series parallel circuit. So, series parallel circuit is further simplified series circuit. So, now you can just see this circuit become in this manner, I mean like with equivalent to R by 3, and then for upper all 3 resistance which are converted, upper delta is connected to equivalent to R by 3 network, and then 2 resistances. So, now you can certainly have of series and parallel connections. So, as you can see 2 parallel connection with upper additional resistance. So, you can easily find out equivalent to of this series parallel connection like. Now, coming to the problems, I mean theoretical problems based on this. So, just to have it just as a summary, the delta connection is also known as a mesh connection, and what is the representation of star connection is also known as a Y or T connection. Well, R A is the resistance at A, R B is the resistance at terminal B, and R C is the resistance at C in a star connection, and after transforming to delta what will be the resistance between B C. So, that relation I mean it is written R at because it is a between B and C. So, you will be certainly R C plus R B and plus R C into R B divided by R A. So, it is easy to remember, or you can write in another way that R A into R C plus R A R B plus R C R B divided by total R A. That is another way you can find out. Like what are the applications of star to delta conversion? Easy to analyze the complex circuit and electronic circuit, and notation of delta connection is the delta, or typically you can call it closed tie connections. If 3 10 ohm resistances are connected in star, then equivalent delta connections resistance are typically 3 into, because it is a 3 times. So, it will be 3 into 10, that is 30 ohm. The question 7, R A is the resistance at A, R B is the resistance at B, and R C is the resistance at C in star connection. After transforming, what will the equivalent to delta? So, R A B will be equal to R A plus R B plus R A R B divided by R C. Similarly, R B C will be sum of R B plus R C plus R C into R B divided by R A, and R C A will be R A plus R C plus R C into R A upon R B. Well, coming to typically some of the solved problems based on this what we discussed today on star delta. So, it is then convert this star network to an equivalent delta network and find the value of equivalent star delta network of value of R A, R B, R C, and then I mean from this circuit you can find out R A is equal to your sum of the 2 star connected, I mean like R 1 plus R 2, that is a 7.5 plus 5 into 7.5 into 5 divided by 3, that will be equal to 25 ohm. As we know in delta the value of the resistances will be higher, that is also by common cross check you can do, and the R B will be equal to again your I mean the 2 resistances typically on the both side of this. So, R 2 plus R 3 divided R 2 R 3 divided by typically your R 1. So, that is also your 7.5 plus 3 I mean, and that will be plus equal to 7.5 into 3 by 5 equal to 15 ohm. Similarly, R C you can find out here R C 2 side resistance are R 1 R 3. So, you can have R 1 5 plus R 3 3 and plus 5 into 3 divided by third resistance of 7.5, that will be equal to 10 ohm. Well, coming to the second question, convert the delta network into star network. Here the resistance are shown here R A, R B, R C, that is a 25 ohm, 15, 10 ohms, and equivalent delta I mean you can find out here, because that equivalent delta will be R 1 will be equal to your R B into R C divided by R A plus R B R C. So, we can keep the value and get the 5 ohm, because in case of a star connection the resistance typical value will be lower. Similarly, R 2 R C upon both side of that will be R C R A upon R B R A plus R B plus R C. So, keeping value it comes like 25 into 10 by 25 into 15 by 50, that comes 7.5 ohm, and R 3 will be R A R B divided by R A plus R B plus R C. So, that is 15 into 10 divided by 50, that comes 3 ohm. So, these resistances you can see in case of a star they are much lower than what you have been having in the delta connection like. So, coming to question 3, using a delta star transformation find the equivalent resistance across AC. So, we have here typically I mean the resistances of typically of 10 ohm, 20 ohm, 30 ohm and 15 ohm with a battery of 2 volt, and we have galvanometer I mean which have a typical resistance of 40 ohm. So, we have to find out of course the resistance equivalent resistance here. So, the equivalent resistance from this side we can easily find out I mean that value of R 1 from this network of this of 10 20 and divide by this typically of your 40 ohm of this. So, that comes 2.86. Similarly, R 2 we can find out, and R 3 that comes 5.72 and 11.4, applying this simple relation of from delta to star conversion. And from this once we know this network gets simplified to, you can call it series with parallel connections, and with addition of 2.86. So, we can have 2 sets of series connected as shown in the relation with the, and equivalent resistance will be 18.04 ohm like. So, coming to the question number 4, calculate the equivalent resistance across terminal A and B. So, you can just see here I mean the circuit looks to be very complicated, but of course, after this conversion of star to delta I mean it becomes quite simplified. So, we have to convert this delta network of G f d into star, then it will become very simplified relation. So, connecting this you can call it G D E into star to delta connections. So, from which we can find out this delta R 1, that is typically of equivalent of this typically two resistances of both the side of it of a star. So, it is 3 plus 3 into 3 divided by 1 ohm. So, that comes equivalent to 15 ohm. Of course, we know in delta the resistances are higher just to make a cross check, and R 2 will be again both the side of this resistance. So, that is 3 into 1 and plus 3 into 1 divided by 3. So, that is 5 ohm. Similarly, for R 3 that is 1 plus 3 into 1 into 3 divided by 3. So, that is a 5 ohm. So, that is equivalent to delta. Now, putting this into network here into delta, now you will say two sets of resistances are coming in parallel, which can be converted equivalent to again to series a single resistance in the another circuit. And now, this form typically the network comes as a 2 delta, as we have discussed earlier the circuit, and this also this delta, one side of delta we convert equivalent to star from using the formula of delta to star. So, you can call it R 1 equal to two sides of it divided by sum of that 1 into 8 divided by 1 plus 5 plus 8. So, that comes 4 by 7 ohm. As we know from star connection resistance are much lower than the delta connection. Similarly, R 2 does that two sides of R 2 that is a 5 into 1 divided by sum of all three resistance 1 plus 5 plus 8. So, that is 5 by 14, and R 3 dash will be two side of resistance of this like typically 8 and 5, 8 into 5 divided by sum of all three resistance 1 plus 5 plus 8 equal to 12 by 7, and we know that in this equivalent star the value of the resistance are much smaller than delta. Now, connecting this equivalent to this this star, now you can see this network become quite simplified is one resistance, then addition of 2 with parallel of that, and we can easily find out this R A B equivalent all and another resistance on this side. So, it comes like a 10 ohm. So, this is a very good example where you are using both the transformation, means like a of these resistances. First we are connecting typically from delta to star, and then after again reducing the network we find the relation of delta to again to star, and then finding the total parallel and series combination. So, this simplified your analysis even quite complicated electrical network of resistances. So, similarly, here we have a calculate equivalent resistance across the terminal A and B, and now you can see here again we have a network related to star connection in between. It is not easy to find out otherwise if we really want to calculate from this. So, again we have to use here this lower star connection into equivalent to typically the delta configuration that will allow the both the side resistance coming into parallel, and this star connection virtually we are converting this this star connection we are converting into delta, and now you can certainly keep these two resistance parallel and these two resistances parallel, and once you connect that you again convert typically this after these two parallel, this network becomes a quite simplified here. Again this becomes a delta, and with this delta you convert again to this star, this delta you connect into star. So, then you can add these resistances. So, it becomes simply a two circuit of parallel with series two set of parallel, and you can find out easily now the equivalent resistance of this network that comes well the sum of these two, thus this sum 2 connecting parallel plus the addition of this resistance. So, it comes 4.23 ohm. So, these are the good example which where we are using both the transformation first from delta to star and star to delta. Now, the question 6, obtain the equivalent resistance R A B for the circuit and use its phi a current I A in this network. So, again you just see here the network is looks to be quite an old one, and however, this network on this side of this you can call it the star, this network of star we can connect to equivalent to a typically into the delta that allow us to go to typically of the resistance will come into parallel. So, we have to find out equivalent to this, and then this network makes the resistance, this resistance parallel, this also parallel and this parallel, and this becomes to quite simplified. Now, we can add this and in parallel to this. So, we can find out with this the complete network resistance of this ohm, and current drawn from the source will be supply voltage divided by your total resistance between A and B, and that comes 12.458 ampere like. Now, coming to question number 7, determine the load current in the branch E F, that is virtually the E F in the circuit shown here. So, we have to virtually convert the entire network that so that this source is connected directly feeding the current to network. So, this initially this delta connection we can convert to equivalent to star and find out the value of this equivalent to star, and this network now becomes equivalent to this network, where you can just now have a connection, typically the two resistance coming in the series, and from once it comes in series you can find out this network becomes quite simplified, connecting this of again equivalent to this, and which can be converted equivalent to this, from which you can find out the total current, and from this total current is the same current which is going into this network like. So, that creates the very simplified circuit finally in your branches like, and to obtain this you can find out now current divided to this network, and that is the current flowing into this resistance like also. So, transform this star connection to delta network. So, you have a 3 and now you can connect into equivalent to delta, just putting the relation, and in delta connection of this we will have a resistance value of higher like. So, that is typically the coming the value equivalent to that. So, calculate the source equivalent resistance in the network shown here in the figure by using the pi t network. Here you can just see it look like a typically a delta network, upper and lower. So, you have to convert this equivalent to this network of a star, that typically the network here, and once it converted to star, then it becomes quite simplified network, and you can have these two resistance in parallel after adding this and final 2 addition of this resistance, and which become total resistance equal to 5 ohm. So, similarly you can have this another example, you have to find out the resistance here again. So, you have to convert again one delta into star, like lower one into star, and find out the resistance which convert typically the network into this. So, now you can add these two resistance with series with this, and you can find out the total resistance of this network like. These are the some of the unsolved problems, on the based of that, which you can probably solve in the similar manner as we discuss it. So, please you can exercise in the same way like on these all these problems equivalent to, they are similar. These are the references for today lecture what we have, and thank you like.